I am Dr. Archita Bhatnagar, Associate Professor, CSE Department, Faculty of Engineering and Technology, SVSU Meerut. So today we will be discussing about data warehouse and Olap fundamentals. Before starting with the data warehouse, we have to think that what was the need of data warehouse and what was the database which was being used before data warehouse came into existence, and why was it needed to bring data warehouse into existence. So before data warehouse, we used to use and we still use the relational database, and its theory says that there are certain tables, the relations, and these are required to be done with the normalization, and everything is done in the particular relation or the particular tables, and these tables are tightly coupled with the primary key of the relation which is being used in parallel with the other relation. This is the example of the tables which were made and which are still made when we use the relational database. For example, there is a relation or there is a table with the name student, there is a table with the name staff, with the name course, and with the name enrolled. So these are the tuples and these are the columns which are being used. For example, enrollment number, the first name, last name, gender, year of registration, and who is the supervisor. Supervisor is from this table, staff. And in this staff table, there is the number of faculty member, means faculty members enrolled number, first name, last name, gender. This is just an example that how are the relations or the tables made in order to show the connection between two tables. What was the problem when we were using the relational database and when we were not using the data warehouse? So the first and foremost and the most important problem was that it was a heterogeneous setup. For example, there is a scientific database, or there are digital libraries, or there is a data from World Wide Web, means internet, or there is some personal database. Every database used to go to different ports, and these heterogeneous interfaces used to be connected with the user. So the user got confused, means on a technical basis, if we see, the user used to get confused that what port or what interface should I go if I need to access the scientific database or any other database. So this was heterogeneous in nature. There were different interfaces, different data representations were there. If interface is different, representation of data will be all together different, and duplicate and inconsistent information used to be there because of these different interfaces. So when data warehouse came into existence, there was an integrated system made. So the data which was there from internet, or the data from the digital libraries, or the scientific data, or personal database, every data used to go on an integrated system, and this integrated system is used by the user for the access of certain kind of data. So it collects and combines the information, every kind of information. These are different sources and different kinds of information. More sources and more different type of information can be there. This is just an example, and it provides the integrated view for the user, and it supports sharing also. This was the traditional research approach in which the integrated system was used by the client. The client asked for the service to the integrated system. This system used to contact to the wrapper for the data. These are the primary sources of data in which every kind of data is stored. Whatever type of data is being needed by the client used to be fetched from this particular source of data, and the wrapper again used to give that data to the integrated system, and then it used to give to the client. But this was on demand. How? When the client asked for a particular kind of data, then only the integrated system would ask for that particular data to wrapper, and then the wrapper used to collect that particular data from the source. So it is on demand. So it takes time. Obviously, if the integrated system does not have any data ready, it has to call for the data from different sources. But in the data warehousing approach, it is different. How? This integrated system already has every kind of data stored. How? There are extractors connected to the different sources of data, and these extractors extract the data and store it on the integrated system beforehand. Before the client asks for the data, all the data is stored on the integrated system. Then what has to be done? The client asks for the data to the data warehouse. This data warehouse just access the integrated system, and integrated system has every data ready. This data is being processed over here. Whatever the cleaning, pre-processing, whatever is needed, it is done over here, and the client gets very clean and very crisp data. So what was the difference between the traditional and this approach? There is data already stored in integrated system in this approach, and in the traditional one, every time the client wants any particular data, it will ask to the sources. So this will take time, and this is in advance stored in the integrated system. So the information is integrated in advance and stored for direct querying and the analysis. This data warehouse gives such kind of data while after pre-processing. It gives such kind of data to the client which is ready for query and which is ready for analysis. Then data warehouse approach, it gives a very good performance, means high query performance is given, because the data warehouse has already processed and cleaned the data to give it to the client. It does not interfere with local processing at the sources. The information is copied at the warehouse part with integrated system. It was there in integrated system that fetched every kind of data from the sources. Different kind of data is stored on the integrated system, and it is fetched by the data warehouse, where all the pre-processing and cleaning, everything is done in order to make it client ready. And information, this data warehouse which is having the information, different kind of data which it is having. So every industry is fond of using that data warehouse only. So database was there and it is still in use in majority of the places, but when we need to analyze the data, when we need it more crisp, the data to be very crisp and very clean and processed, then we need to have data warehouse. Now we come on the most important question, that what is data warehouse? We have discussed that what it does. Now the question arises, what database is? So it is a single, a complete and a consistent storage of data which has every type of data, every single business data is there on that data warehouse, and we can just access that data and we can have clean pre-processed data which is ready for analysis. Data warehouse is subject oriented, it is integrated, time varying and non-volatile collection of data which is used in the organizational decision making, like analysis is to be done. So it is a complete package. It is the stored collection of diverse data, as I told in earlier slides. The different kind of data, whatever the data may be, it may be scientific data, it may be the data from internet, it may be any display data, any personal data, every type of data which is provided by the source, it is integrated on the data warehouse. It is optimized differently from the transaction oriented DB and user interface aimed at executive type of data. Large amount of data can be stored, like in GBs and in TBs. This much amount of data can be stored in data warehouse. It is non-volatile, like much older data like historic data or the data in which time attributes is very old, that data is also stored on data warehouse without getting hampered. And updates is infrequent, means it does not require frequent updates, and it may be append only, means upgraded versions of data warehouse can be used for different kind of applications. Now we'll discuss about the Olap, online analytical processing. The goal of Olap is to support the ad hoc querying for business analysts. Whenever there is a need of analysis to be done on any kind of data for any kind of business, there are some queries which are ad hoc, means on-time queries. So this type of queries can be handled if we use Olap servers. The business analysts are familiar with these spreadsheets, so the spreadsheets are extended to do the analysis part, and this model works with the warehouse data. Whatever the data is provided by the warehouse to the client, it is handled by the Olap servers for analyzing the data into the spreadsheets, mostly into the spreadsheets. It is the multi-dimensional view of data. Now we'll compare Olap with OLTP. OLTP is online transaction processing, and it is used to perform the updates on the operational or transactional data. Whereas in online analytical processing, that is Olap, we are doing the analysis of data which is complex in nature. This is the tabular format of the differentiation between OLTP and Olap. We have, when we talk about the user, OLTP is being used by at the clerical level or at IT professional level. And if we talk about Olap, knowledge workers or data miners or data scientists, these people use Olap. What is the function? It is day-to-day operations like transactions of money or any kind of transactions. If we are doing, it is day-to-day operations. But Olap, the operation or the function is decision support. Means if we are working for any particular analysis, we have to do that particular analysis only. What is the design of the database? It is application oriented, that is entity relationship model can be operated, and it is subject oriented, that is schemas can be operated on the Olap. Then data, current and isolated data is used for transactions, different transactions, and for the analysis we have to use historical or consolidated data. What is the view? It is detailed or relational view, and it is summarized or multidimensional view in Olap. Structured and repetitive views can be there for transactions, and for analysis ad hoc usage is there. As I told before, ad hoc means on time, whatever the analysis is to be done, it is on time. Then short and simple transactions are there in OLTP, and in Olap complex queries run. Then read-write operations can be there or can be used in OLTP, and read operation mostly is done in Olap. Then the index or hash on primary key is put on transactions, and lots of scans are done with analysis part. Number of records, tens or hundreds of records can be accessed. Millions are accessed in analysis. Number of users are thousands in transaction, because it is easier and it is more reachable. And since it is not more reachable and some complexity is there in analysis part, so hundreds of users are only using the Olap. 100 MB to certain GB is the size, DB size of OLTP, and for Olap it is 100 GB till certain TB. and transactional throughput is there in transaction, and in Olap it is query throughput and response. Now we have three types of Olap servers, that is multidimensional Olap, relational Olap, and third one is hybrid Olap, which is combination of M Olap and R Olap. So M Olap is array based storage structures, because we are talking about multi dimensions, and it is direct access to the array of data structures. And in R Olap, that is relational Olap, we deal with relations and specialized relations of to store and manage the warehouse data. We'll talk about M Olap. M Olap, as I told, that it is multi-dimensions. So we have certain different kinds of dimensions which are included in this data storage. For example, this is the date part, this is the product part, this is how many number or the functions of time it is taking, and this is the city part, which is stored in this kind of storage, which is known as data cube. This is the multi-dimensional storage area which can handle all these dimensions at once. So this is the multi-dimensional database. What are the operations which we carry out on the multi-dimensional database or in Olap, M Olap are aggregation. It is also known as roll-up. For example, if we are talking about any total sales in particular city, so we have that one dimension, and in particular city. So this is the dimensionality reduction. Only one dimension is used for sales in a particular city. Total sales, we are not putting any particular like a 50% sale or 10% sale, and nothing is provided. Only total number of sales in a particular city. So it is reducing the dimension. Dimensionality reduction is provided over here. Then we have second operation is selection operation, also known as slicing. So slicing is particular, we are putting a which city is there and what date the sales are being done. So this is defining a subcube. Like if we slice any apple, we get an internal view of that apple. Similarly, when we are selecting or slicing this particular multi-dimensional data cube, basically we get an internal view of that data cube in which any particular data is being stored. Third operation is navigation to the details, also known as drill down operation. For example, any sales or any expenses by city, and in that also top 3% of the cities. So we are applying more than one conditions. And fourth one is visualization operation, also known as pivot, which we will discuss in next slide. This is the pivot in which we are rotating this particular database or the data cube we are rotating, and we are getting different kind of views. Like in the data in that cube game, when we rotate any particular slice, we get different views of that particular cube. In similar manner, when we are rotating, we get view of product, we get view of region, we get view of month, we get view of any timeline. So this is how the pivot works. Now R Olap, that is relational Olap. There is a schema design used for defining the rules in relations, because we are not in the M Olap, we were talking about the data cube. The data was stored in a multi-dimensional database, multi-dimensional area, that was cube. But in this, relations are used. That's why to operate those relations, we need some designs that is known as schema designs. These are specialized scans, indexing and join techniques are used for connecting one or more relations with each other, because when we are applying analysis on any particular data, we cannot rely on one database only or one relation only. We have to see through more than one relations. Then supporting query languages, queries are given for extracting the data, and majorly we are using SQL. Complex query processing and optimization can be done because the data is in relations. So queries and the optimization part can be done easily, and complex queries can also run. And data partitioning can be done. The data from one relation to another relation can be partitioned, and they may be used as parallels. Now what is the now we are giving Olap versus Olap, means only Olap when we are using, and how we are differentiating it with Olap. The commercial offerings of both types are available, means both are used commercially. Olap is good for smaller warehouses because in that we have to make a data queue. So if comparatively smaller data warehouses are there, then we can use Olap. And in another Olap, if we are using, because relations are provided, that is why it is flexible in nature. These are performance based, and they give good and flexible performances. These are certain tools which are used in warehouse servers. For example, Oracle, IBM DB2, Informix, these are certain tools. These are tools for Olap servers. Like in our Olap servers, the data stored, it is stored in relational tables, and in Olap it is stored in array based structure, like multi-dimensional tables. And this is the hybrid Olap, in which the combination of R Olap and Olap is given. These are the extraction, transformation and load ETL, which is given for these are the tools which are provided for ETL. And for report and query, these are certain tools. For data mining, we are using data miners, decision series, enterprise miners. So this was all about the data warehouse and the Olap servers, and how the data warehouse is increasing day by day, and why is it used for general purpose. So I hope you have got what I tried to make you understand. Jai Hind.